Hello everyone, welcome back to Coding Intuition. Today we are going to solve reorder routes to make all paths lead to the city zero question on LeetCode. So let us begin by understanding the question. So in this question we are given an array which basically represents a graph in which we have directed edges. In this case, directed edges means if we are given 0 to 1, we can only go from 0 to 1. Let us consider 0 as a city and 1 as a city. So if we are given 0 1 here, we can go from 0 to 1 but cannot come back from 1 to 0. Okay, so that is what we have given in the question. Like we can go from 1 to 3, and we can come back from 2 to 3, and like that. So what we need to identify in this question, that 0 is our home basically, and we need home city basically, and we need to identify how many edges we need to reverse in order that we can reach our home back. And it is granted that there will be a solution for this question. So let us just understand it by first example. So as given in this first example, like we are going from 0 to 1, so there is no way this one from this one city we can come back to 0. So that is what we need to do here. We will cancel this and move this back. So we will change the direction of this edge. We will change the direction of this edge from 1 to 0. Similarly, from this, in this case, we will not be able to come back to 0. So we will change the direction of the edge. So we need to return the minimum number of edges, direction of edges we need to change in order to return back to 0. So that is what the question wants to say us. So uh, let us move to the whiteboard and try to understand intuition behind solving this question. Now, to understand the solution, let us consider this input as an tree. Okay, so in the solution, let's see which are the problem, which are the edges which can create some problem. Okay, so in this solution, as we can see, this edge is going from 0 to 2, so it will not never come back here. And this edge is going from 1 to 3, so it will never allow us to come back from 3 to 0. Okay, and this edge is going from 2 to 6, so this will also never allow us to come back to 0. So what we need to do, we need to revert these edges back like this. Okay, so in this question, what we will be doing is, when we will be creating an adjacency list for traversing our graph either by breadth first search or by depth first search, we will be adding, we will not only add the directed edges, we will add edges for the both sides. So for example, we are given in our question 0 2, so we will also add 2 0 inside our adjacency list. So now what will that do for us? Okay, so for with each as we are adding inside our solution, we will also add a boolean value against it. If this is an original edge, which means which is present inside our solution, we will add a boolean value true against it. Okay, we will add boolean value true against it. And if it is a node which is and with edge which is not existing inside our solution, but we are creating that edge for just for making our solution work, we will say that it is false. So when we add 0 2 in our adjacency list, we will say it is true, and when we add 2 0 in our adjacency list, we will say it is false. Now what we need to understand here is that whenever we are in a tree and we need to come back to its parent, it is necessary that we should have uh, a edge which is pointing upwards. So if we have an edge which is pointing downwards, it will never come back to its parents again. So now, so basically what we need to do is we just need to calculate all the downgoing edges inside this tree. Yes, as we can see, we have here one downgoing edge is in this side tree, and this is another downgoing edge, and this is another downgoing edge. So the answer for this would be 3. We need to change 3 edges on this. And how we will be doing that? We will be creating, we will be adding both edges for both sides uh, in our adjacency list. So as we add this downgoing edge which is not already inside our given question, we will mark it as false. Okay, and we'll mark this one as true inside our adjacency list. So now whenever we are going from top to bottom in the tree, we will always be going through these downgoing edges. We will never go down through this upward edges. Okay, so when either we solve it from breadth first search or depth from search, we will be going through these downgoing edges. In this case, we will be going with these downgoing edges. So either it is existing or we have created it in our adjacency list. We will be going down the tree by downgoing edges only. Okay, so now we will calculate how many times we have encountered true. That is our answer basically. So we will set this true for this, and and upgoing edge for this will be false. So we will check, and we will be going only down the tree only through downgoing edges when we do depth first search. So we will calculate, whenever the true comes, we will increment our answer. That is what we need to do in this question. As we see here, we will be doing the same thing, and here if we see, we will going down through this edge, and for this edge, our we will set a boolean value to false. So in this case, we will be not calculating anything, because this is a correct edge. We need all the edges pointing upwards, because we need to come back to zero. So that is what is intuition and algorithm we will be following in this question. So now let us just write the code for breadth first search and depth first search. That will make this question very much clear to you. First of all, let's write that for search code. Then we'll be writing breadth for search code. Okay. So first of all, let us just declare an adjacency list. In this adjacency list, we will have a pair in which we will be having the neighbors and a boolean value if it is uh, originally given edge in the question, or we are just adding it, adding a reverse edge for that. Okay. For the coming back edge, for that we can say that. Okay. So now we have declared it of the size n, because we have n nodes from 0 to n minus 1. Now we will iterate over the array connections. So in array connections, uh, we have an array inside it which have the connection between the two nodes. So let's say connection in connections. Now what we need to do, we need to add it to our adjacency list. So connection of 0 would be this. So this is the node we are adding, which is basically a node which is already given in the question. So it is already given to us in the question that we will be going from 0 to 1, but it is not given that we can go from uh, 1 to 0. Okay. True added at end represents it as given in the question, and for the opposite thing, we will just mark it as false and say that we are going from 1 to 0 now. We are going from 1 to 0. So we have created a adjacency list, and we will need a visited array to check if the current node are visited or not. So we will just create an visited array of size n, as we have n nodes, and initialize all of them to false, and let's initialize our answer to 0, and let's just run DFS. In DFS, we will be passing adjacency list, visited node, and our answer. And from the node we are starting from the 0th node to do the depth first search, and we'll check along the way if there how many nodes are there which are going down, not coming upwards. Okay. And at the end, we will return the answer. So now let us just write the fs method here. So in the fs method, we are passing our adjacency list. With adjacency list, we will pass a visited array. Let's say vector is a boolean vector called visited, and now let us pass our answer. We will also pass this by reference, because we need to change our answer and our current node from which we are starting down that first search. Now let us just mark our current node to be visited, and we will iterate over the neighbors of our current at this our current element. So our current element is 0, and we will iterate over all of it adjacent childs. Okay. So we will say our if this child has a value true, it is going downwards. So and it is really present, and it is going downwards. So we will say we will add answer to second to our answer. Basically, we are adding true to our answer, it will convert it into integer and add 1. If this is false, it will add 0 to the answer. So basically, if it is true, it will add 1, and it is similar as saying 1 and 0 here. This will change nothing inside our answer. Okay. uh, Now we have added uh, to our answer if it is going downwards node, and it is originally present inside our question, not added by us. Okay. Now let's just run the DFS over its child. Now we will run the DFS over its child. We will just pass child dot first, which is basically the value of its neighbors. Okay. So that is the code for that first search. Let us just run and try if it is working. Okay, there are some compilation errors. Let me just fix them and get back to you. So I have fixed this. One thing I've missed here to check if it is visited or not. So we obviously need to check if the node is visited. We will not visit that again. And another thing was that the some spellings was wrong for answer and first. So that is a solution on the DF that first search. So now let us just move for writing the code for breadth first search. So for our breadth first search solution, the first of all we will similarly create an adjacency list, how as we have done in our breadth first search solution. And now let us just start it. So first of all we will mark our 0 as visited because it will be visited at first. So let us just mark this visited. Now let us just create a queue of integers. Basically it will contain our value of our nodes in integers. So first of all, our first node we are going to is 0. So we will push 0 inside this. Now we will initiate our answer to 0 again, and we will check while this queue is not empty. So while this queue is not empty, we will say current is equal to queue dot front, basically getting the front element from the queue and popping that out from the queue. And now similarly we will iterate over all over the neighbors of the current. So we will say auto and child in adjacent of our current node would be this. So we will first check our if it is not visited, only then we will go inside this. If it is not visited, so we will say uh, first of all we will say answer plus equals to, because it will be the node going in opposite direction, node coming back to the 0. So that's why we will just add it to answer, and then we'll say it is visited now, and we will push this inside the queue. That is was basically the difference between breadth first search and depth first search. In depth first search, basically we are using a stack and going in the depth of the tree first. In breadth first search, we just go kind of level by level. Okay, so we have pushed this in the queue, and I guess that is it about breadth first search solution. So just let us just return the answer and check if it is working or not. So there are some compilation errors. Let me just pause it and get back. So there was just a spelling mistake in this first. So now I have corrected it. Let us just submit and see if it is working. Yes, it is working and accepted. So thank you so much for watching. I hope this video has helped you. Bye bye.